I'm continuing to have fun with Smalltalk 72.
Very nice.
Awesome.
So I hope to have some of this version out for people to play with in a week. Yeah, a week or two, probably. My wife has to go away for about a week at the end of the month, and that's when everything will surely get done.
So what are you doing to it? What are you doing to get it going?
Well, so this is a project that I've had for a while, and I I did a serious run at it earlier this year in JavaScript, and got one. So the first serious aspect is to is to have the only state around be the context stack. So the whole thing is described by this current context gets current context next. And I did that all in JavaScript with an aim to make it really fast, and I succeeded in that. So it runs about 700 times the speed of the original Smalltalk 72, which is great. The only thing is that it's in JavaScript, and I realized after that we've got. I had an earlier version that's not as clean in Squeak, and Vanessa has Squeak.js running so nicely. I thought, this is really wrong. It ought to all be in Smalltalk. I mean, the very latest Smalltalk ought to be running the very earliest. So that's what I'm doing right now. And,
very cool.
Yeah, I don't think there's anything wrong with making a fast eval in JavaScript.
Yeah. Well, I have fun doing it, I guess. Yeah.
Yeah, just for the fun. Yeah.
But and for those to whom I haven't already said this, the purpose in making a really fast one was that I want this Smalltalk 72 to run itself the way you can in Squeak or in Smalltalk 76, and have the interpreter, the Smalltalk 72 version of the interpreter, which Alan never really finished, running itself and be usable. So that's the end goal. That's the Christmas goal.
And you want that usable in Squeak.js running?
Oh, absolutely. Yeah.
Yeah.
Okay, so I might have some time to work on Digit later this year, because unless I do that, I don't think you're gonna be happy.
Well, so that may be true, Vanessa, but don't despair. It's
okay.
It's running really well.
All right.
Yeah.
I take your word.
At least I'll be a good test case for you.
True. I guess you can buy one of those new MacBooks who supposedly are really fast at JavaScript.
Oh.
The M1 processor. And maybe the M2 is going to come out later this year.
Yeah, I heard it was the M2 is already coming out. Yeah.
Right.
Later, in a couple months, right?
Mm-hmm. Maybe before Christmas.
That would be cool. I think that's the one I want. I need 4 ports.
Mm-hmm. Yeah, there's so many rumors, right? Like, real ports are back, and the weird touch bar is gone. Yeah.
The touch bar is gone?
I like the touch bar. Oh well.
I think so.
I like it, except for the escape key is one I kind of expect to be tactile.
I have the one that has a tactile escape key.
Yeah, same here. And you can program the touch bar to do all sorts of cool stuff.
Oh yeah, no, I like the touch bar. I also think the haptic trackpad is kind of cool. It was years before I realized that wasn't like a mechanical spring.
Mm-hmm. That is very weird. Yeah. I had a machine die on me, like it froze up so hard the touchpad wasn't active anymore. It is really just a hunk of metal. Like, it doesn't do anything. That's so weird.
Okay, this could be. Oh, here's Ted. Hey, Ted.
Hey, Dad. Oh, we should ask Ted too if he maybe wants to present something, talk about random small talk stuff.
Yeah, a TED Talk.
A TED Talk. Yeah. How about that? No, we
Well,
are
it's kind of
actually
short
looking for
notice.
speakers. No, not
I
today,
see.
but
In the future. Yeah.
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 Well, unless you have a
Once-
lightning
once
talk.
a month.
We do this every time.
Yeah.
Yes.
Mhm.
Yeah. Maybe I'll have a couple ideas.
Good.
Hello,
We have a
everyone.
couple slots.
Uh-huh.
Mhm. So let's see. Dan, why don't you call us to order? Although I think everyone has been here before.
Wait, you still have to unmute so we can hear you. Then you have to unmute.
Can I unmute him?
No.
No.
It's the icon on the left inside of this 8x8 thing here. There we go. Oh, no. You're still muted. There.
Did I do it?
Yes.
Yeah.
Yay!
I've got announcements scrolling by announcements of live streaming and lobby and all this other crap here for 8x8.
And that's over the
Oh.
button. Yeah, I hate that.
My apologies. Okay.
No worries. Let's see if I can turn this off.
So anyway, this is our monthly meeting of the California Smalltalkers, and we often start out by soliciting anybody who has a disorganized or organized brief announcement or talk to put in the beginning. And then we usually have somebody who's actually got a plan for us for an organized presentation. And did we end up getting one? We had one that was close, and
we volunteered Craig. Yeah.
Yeah.
Oh,
I'm
great.
gonna
That's awesome.
that clean up for the speaker who has been deferred.
That's awesome.
Yeah.
And also welcome to all the non-California visitors.
Yes,
Hi.
indeed. Yep. And so that's all I had to say by way of introduction. I have a really brief thing to bring up at some point if, when we're done with other suggestions of announcements and stuff. Anybody want to pipe up? Well, I'll give mine then, just as a brief thing, which is Craig and I have been chatting and with Vanessa occasionally, I think, about, and this was triggered, the thought was triggered again for me by listening to the UK Smalltalkers when Dave Unger mentioned just having a system that's just convenient to use, like self-running on an iPad, that you would just choose over other things to pull out at any moment and quickly compute something. And that's something that has been dear to my heart since the very, very beginning. I remember the inspiration for the Lively Kernel was that you would find yourself at a bus terminal leaving town, and you would quickly draw a picture of a heart and be able to make it throb and send a message to your sweetie as you left town, that kind of thing. And it made me think that, and that together with a recent experience with Squeak in the form of Squeak.js, I have been pouring time into that, working on Smalltalk 72. And when the regular Smalltalk part is just fine. It's as good as it ever was. But I did a little bit of work on the user interface to make a sort of a debugging console and stuff like that. And it seemed like it had gotten more complicated than it used to be. And so those two thoughts together made me think, gee, is it time for us for some little cadre of minimalist type people to pull together a sort of a, some kind of New Year's version of Squeak to go on top of Squeak.js that would somehow be the perfect minimal thing that would be good for anybody who wanted to play. And so it ought to have some easy way into sounds. It ought to have some easy way into graphics, some easy way into numbers, and some easy way into text. But not be, not be huge. And actually, it's nice now we can look at that from the perspective of eToys, which actually does a great job of a number of things and provides a number of cool tools. But I thought this would be an appropriate meeting, and we probably should go out to a bunch of people who aren't here, but people who would be users of such a system, and more importantly, critics of such a system going out. And I know that Craig has also worked on things like this in the past. So that's my thought. Is would it be fun to have a little project that we sort of move along with each one of these meetings that's a cool pad-born, Squeak.js born, minimal, but very fun Squeak or Quiz,
Mm-hmm.
That's an awesome idea.
Very cool.
Everyone wants that. We just have to build it.
Yeah.
Simplicity is a little bit hard because different people have different views.
Yes.
For example, for somebody, if you have 5 dialog boxes, that's simple. Whereas if you have a different mentality, if you have a single dialog box where you can type in a regular expression and it will do the job of the other 5 and will do many other things besides, that's what's simple, if you think that way. Yep. But a lot of people have asked me, because John Maloney gave an interview to Squeak News, and he talked about the relief of coming back from Self back to Smalltalk, to Squeak. And then, since everybody knows that I was involved with Self, did ask, oh, what did John Maloney mean by that? Of course, you'd have to ask him. I can only guess what he meant. But one thing that I thought that might be possible is that in Squeak, you'd open up the system browser and there was a list of everything in there. Where in Self, it was like an adventure game. You'd never know if there was an object that you hadn't run across because you can put them anywhere. So my impression was that he liked the idea that it was a closed system. But that was back then. As soon as we started putting packages on the internet, that's no longer true. You open up in an image and you don't know everything that's available for Squeak. You'd have to know to get Monticello and to load packages and stuff like that. So that was never a long-term thing. But another thing is that some people don't like the way that Self uses slots and parents for everything. They like to have classes and pools and stuff like that. So that's something that I found that I thought it was wonderful that you could use a single idea to replace 6 ideas in traditional Smalltalk, but a lot of people hate that. They really don't like that. They want to have this language features for this and this language features for that. Don't try to have a single mechanism for everything.
That's a deep topic, I think, which is, Lisp in some sense is the right among the purest, simplest. Well, you'd have to, fourth would be another, but systems, it's not, people like to work with variety, and even this, we learned this doing one of the fonts for Smalltalk 76. in which we made a font in which all the letters were made out of the same shapes. We called it cream. It was just so smooth. But it turned out you couldn't read it well. And it actually is nice to have little serifs, little twitches on each letter, because you can sort of anchor yourself to that, and it immediately means something. And yeah, what you're saying is exactly right. So it's a line you have to follow between everything being the same and everything being sort of iconic and recognizable.
And the advantage is if you have a group of people, and hopefully they'll think differently. They won't all think alike, and then you avoid that kind of trap of making something that's really simple for me, but everybody else hates. So yeah, that's why I think this would profit by having a bunch of people involved. Not too many. I've been there, but not too few. Also, yeah. So other thoughts on this, or other topics to bring up?
Or any little lightning talks or demos?
Yeah. Okay, well then, that being the case, I think it would be time for me to introduce our speaker of the night, Craig Latta, who's going to talk to us about
WebRTC.
WebRTC.
WebRTC. Awesome.
It's actually exciting. Yay.
It's pretty exciting. This is continuing a tradition of speaking about things that have just started working. So apologies in advance if it stops working. But I think this is the beginning of something exciting. I've been working on both peer-to-peer communication between Smalltalks, and those Smalltalks have mostly been in web browsers. So I've been using Vanessa's Squeak.js virtual machine that Dan just mentioned. And I've also been playing around with another one of Vanessa's projects, Croquet, the new Croquet company at croquet.io. In fact, I not too long ago spoke about another project of mine that just started working that also uses Croquet, the beat shifting music project, to get peers in web browsers to be able to play music together using a diabolical form of time shifting on a micro level. So this is another Croquet app that tries to make the notoriously difficult process of setting up a WebRTC data channel connection simpler. And I think it actually does make it simpler. And it provides another great example of how actually live coding with open web APIs is a really useful thing. And yeah, so one big trend in all of this work I've been doing with web stuff and Squeak.js is to provide actual live coding in a web browser. JavaScript is, extremely dynamic, very much inspired by the extreme dynamism of self that Giselle was just talking about. But it's not usually used that way, especially since the rise of transpilation in the JavaScript community with things like TypeScript. So a lot of things from the old static models of development are creeping back into JavaScript and web development. Now it's quite common and almost de rigueur to go through build steps and static typing and things like that in contemporary JS development environments. So I'm sort of trying to show an alternative to all of that by going in the other direction and being extremely live and dynamic with Squeak in the web browser, and showing that you really are losing something when you make a system that requires you to statically build it and test it to a point where something goes wrong, and then you sort of have to give up all the state that you built up to get to that point by having to reload or rebuild or retranspile or whatever it is that's involved in actually deploying your app. So at this point, I'm gonna try to share my screen. And there's gonna be a lot on there. I've made everything as big as I could to be readable on, I guess, a 1080p screen for YouTube. And hopefully no one is looking at this on an iPad, because I did that earlier today and it was really just too small. So hopefully you all have enough pixels to see what's going on. What I've got here are two web browsers. Oh, first of all, I should check. I checked this earlier today, but I'm hoping you can all both see my mouse cursor, which is moving around. And you can also see if I zoom in using the macOS zooming, that it actually zooms. Okay.
That's working, yeah.
Yeah, good. So just let me know if at any time there's just too much detail and I need to zoom in on something. I could probably do it. So on the left, we have Google Chrome running Squeak.js. And the image it's running is the Caffeine image I've been working on. And Caffeine sort of takes the JavaScript bridge that you get from Squeak.js and really runs with it, using that bridge to talk to all sorts of different JS frameworks. There are a gazillion of them now. And I've been sort of making my way through what I think are the most interesting ones. Croquet is definitely one of them. And like the A-frame virtual reality system from Mozilla is another one. I gave a talk about that at the UK Smalltalkers group a couple months ago. So Caffeine adds a bunch of Smalltalk interfaces to JavaScript things that you can use from Smalltalk. So you can, create Smalltalk objects, which are proxies to things like HTML elements and other DOM things, or A-frame things, or Croquet things, and just play with them from Smalltalk, as if they were, made there in the first place. And you can see more about that at caffeine.js.org. And yeah, I'll, I guess, collect the equivalent of show notes to go along with the YouTube video that we're recording right now that'll have links in it. I guess before I forget, I'll sort of run through the most important links that will arise out of this talk. Caffeine.js.org is the first one. Oops, we're not in Holland anymore. And later on, we'll be looking at a description of how WebRTC signaling works from the Mozilla site. There's a very useful set of diagrams about how the conversation goes over there. That's at developer.mozilla.org. And then the Croquet API docs, which are at croquet.io/SDK/docs. So that's what's happening in this quadrant of this massive screen. And then the Chrome debugger is open underneath that. When I press the magic button to hopefully make signaling happen, you'll see a bunch of messages go by here. And likewise, on the right half of the screen, I've got Firefox running. That will sort of be our first peer or second peer, depending how you count. And again, I have the development tools, the dev tools console of Firefox open in the lower part here. And I figured I would proceed just by seeing if this still works like it did an hour ago. So what I'm going to do is join a croquet session and create a croquet model, which is will be replicated amongst all the peers who join this croquet session, and a croquet view, which will implement a bunch of the WebRTC peer stuff in this example. So there are sort of two sets of terminology that I'll be thinking around: the croquet set of terms, model and view, and the application-specific terms here for WebRTC, which I'm calling cafe instead of the generic model term. That's the thing sort of coordinating the comings and goings of all the peers and managing how they broadcast what they can do and setting up connections. We'll get deeper into that. And then, yeah, instead of croquet's view, I use the word peer. So hopefully that's not too confusing. There's two sets of two terms each that I'll be thinking around. And yeah, hopefully I won't need to get too deeply into croquet stuff, but Vanessa will correct me if I say anything wrong about that. Sorry, Vanessa?
No. Yeah, I just think if the model is the cafe, then maybe the views should be the patrons or something like that.
Yeah, I've been thinking about different terms for that. Well, I was thinking of just discarding any sort of metaphors at all. I thought cafe was kind of a cute thing to use, but then yeah, do you say peer so as not to confuse people who are expecting the word peer because they're familiar with WebRTC, or do you continue the metaphor? I haven't really decided, but yeah, that's a very good point. I'm kind of thinking I'd like to maximize the number of common words. That may minimize rather than maximize confusion, but I'm not sure yet. And I already see one bug. Normally here in the DevTools console, you would be seeing messages from cafe and peer, but I only see an empty string here for these first three. But this is the cafe talking, that it has started its croquet session, and it's added a peer that's running in this web browser. And then the first thing croquet model does after it starts a session is replay events that may have happened in this session before. And I'm not going to say too much about that yet. But again, Vanessa, please jump in if you like at any time about croquet things. But the basic idea is that the model replays what has happened before since its last what's called a snapshot to bring its state up to date. And then it is up to croquet views to synchronize themselves with that updated model so that they are also in a coherent starting point for the session. So that's what's going on here at the beginning. And then right away we get into WebRTC related stuff. Croquet itself does a very good job of letting you publish scoped events to all of your views. Well, to all of the participants in the session. And that I'm using that in this WebRTC example to both deal with the arrivals and departures of peers in a session, and also to relay messages between peers. And we'll see from the WebRTC spec, there are a lot of things to relay. The first thing that gets relayed here is a message from the peer to the, I'm sorry, the first croquet event that gets published here is from this peer running in Chrome here to the model or the cafe, saying that it would like to broadcast to all the peers there are what it can do. And this is a thing which is larger than just WebRTC. This is part of something I'm working on for providing a set of services that any Smalltalk in the session might find useful. Not only WebRTC, but also the service of providing storage for an object memory snapshot for another peer. And that's an example that I was motivated to do from mobile devices. Some of the peers that I've been working with are like iPads and phones, which do have ways of storing files, but they're not so easy to get at as on a traditional laptop or desktop computer. So like the first service I want to do once I've got these WebRTC data channels set up for streaming across is to be able to be using Squeak.js on your iPad, and you want to make a snapshot somewhere that's sort of fail-safe off the device. And I would like any other peer that you can see in your session to be able to provide that service for you. And another one is history services. Another thing that I've spoken about in Smalltalk is a module system that I've been writing called Naiad, which sort of transcends the changes and sources file that you traditionally have in Smalltalk with a whole other dedicated object memory that's running, and it can sort of act like a flight recorder for a development system. So I envision a scheme where you're working in your normal object memory, developing things, and you've got this other little tiny one paired with you that is sort of listening and recording everything you're doing. And sort of, so it's a history system. It's keeping track of all the classes you've defined and methods you've changed, all the versions of all those methods, and so on. And this will, and you can get those little history systems of a bunch of people all talking to each other. So this will be the basis for a team development system that can, notify you of various things. Like if a teammate of yours has, changed a method in some class that you're responsible for in your team, these collaborating history systems could notify you of that. And to make all that happen, I'll be using these WebRTC data channels for doing remote messaging between peers and for communicating between history systems. So anyway, sorry, that was a bit of detail, but just suffice it to say there are a bunch of services that I'd like to provide that are going to actually be sending bits over these channels. And the first message that a peer says is, which of those it can do. And the next thing here is the peer saying that it has heard from the croquet model that a peer has entered, which happens to be itself. That's why it refers to itself as to the peer as local. And then this request to broadcast that the peer sent to the model actually does get broadcast as a service announcement to all the peers, and that peer receives it and says that it's ignoring its own service announcement. It doesn't need to take any action about that. Okay, so now we've got one peer sitting here having announced what it can do to no one but itself. So now we, sorry. Yeah.
So the croquet model, which I think you called the cafe, that is that also hosted in the same image we see in the Chrome browser?
Yeah. All of these peers are starting from the same Squeak snapshot. And they can act in any of these roles. And it doesn't matter which one starts first. And even if you like go to another tab here, I think the timeout is like 20 or 30 seconds. Croquet actually notices when you haven't been using the tab that your croquet session is in for a while, and can revive your session properly, including replaying any events it may have missed that were published by other peers. Probably long enough. So if we go back here, you see these 3 dots here. And then if I go back to here, which is where it ignored its own service announcement the first time, that's when I switched tabs to that other one. And then I came back and we get a reconstruction of the session, including the model replaying what it needs to bring itself up to date. There's nothing to replace. That's not very interesting. And the peer synchronizing with the updated model state. And then every event that happened the first time gets replayed and, at this point, republished. So this is, sort of the essence of the croquet distributed computation, is that it can bring everyone back up to date, coherently with no divergence, even to the point of, bending how random numbers work a little bit so that everything stays coherent, really coherent. Yeah, so we see, from these replays that exactly the same things have happened. And hopefully we'll see later that this works even if I already have a WebRTC data channel set up between these 2 peers. If I make both of these web browsers go into different tabs and then bring them back, it will go through again the WebRTC signaling in exactly the same way and set up the channel exactly the way it was. I've noticed a little bit of flakiness about this somewhere in Firefox, but not in Safari, and not in Chrome. But I'm using Firefox tonight just because there's a few key bindings that Safari insists on not letting you use in Squeak.js that I haven't figured out how to work around yet. Although I'm sure I will. This has happened to me before, and every time I've emerged victorious, but I haven't yet. Normally I would choose Safari because it's faster than Firefox, even with the debugger open, but Firefox isn't so bad, so I'm just going with that this time because it actually lets me do all the weird key bindings I want to do, and somehow during demos that turns out to be especially important. So I'll go over here to Firefox and join the session, and now we'll see a whole bunch of stuff. I'll scroll back through a bunch of this stuff, but first I just want to do the fun part. So if I go here to this workspace over back in Chrome, I'm going to try to send some data over that channel that I just opened. And we see over here in Firefox debugger, web browser debugger, that it received that event. Then if I go over here to Squeak.js in Firefox, I could do a similar thing and see that, yes, we've made a round trip. So yeah, this is sort of the hello world of WebRTC. And I think even though we've only done hello world, I have found it extremely valuable getting to this point in being able to do everything in a live coded style. Before I, even started reading the WebRTC spec, I looked at other apps that use WebRTC data channels to do things, just to see, how tricky it was to actually hash through all this stuff. The best example I ended up looking at was a thing called Snapdrop, which provides this cute sort of simulation of the Apple AirDrop functionality, only running in web browsers. And it worked quite well. But as I looked through the code, I realized, man, this guy must have taken weeks to figure this out, to get to this point, as I really looked closely through all the code. And even sort of trying to distill the most important parts of his code into something that I could, transcribe into Smalltalk Think was not easy. Even just tracing the flow control through his code was really tricky. And it at some point after I understood the concepts, I ended up just having to stop looking at it and just refer to this diagram instead. Occasionally, like maybe the first couple of times I went through this diagram, I would sort of cross-reference it with what I could see in the Snapdrop code.
I got a question again.
Yeah.
This is more of a WebRTC. I was kind of curious how you got rendezvous between two images that don't really know anything other than that string you said 125. I'm guessing it's that brown signaling server in the middle of your left diagram.
Oh yeah, sorry, I'm hiding way too much with these simple workspace expressions. That 125 is an identifier for a croquet session. So that's a croquet detail that you're seeing
Right.
there.
But in terms of rendezvous, how where does the like a name server, something that says this is how you find a croquet session given only the name 125?
Oh, we can look at that. But basically, I'm using the croquet service to do this. So it's the croquet network of what they call reflectors that is helping us there.
I kind of remember croquet from like maybe a decade ago when they used the term like island and router. Is the same kind of thing?
There are some of the same concepts in this implementation, but it is very different. And I think it is much simpler. And Vanessa can talk more about that.
So
the trick is we are running reflectors 24/7, and the client automatically connects to that. That's how the rendezvous happens.
So when you say the croquet service, you're not talking about a piece of software. You're talking about a persistent service out there on the internet that Croquet, the company, is hosting.
Yeah.
Exactly.
Gotcha. And that would be that brown thing in the middle, the signaling server.
No.
No. Okay.
No. All of this drawing is about WebRTC. And yeah, there's a whole other thing that we'll be talking about.
Okay, but basically that croquet service, persistent service, what you call it, a reflector, basically lets you find the proper endpoint given the string 125.
That lets me join a session, a croquet session, which has a very long and complicated identifier, some of which is 125.
Right, but in terms of actually getting to the actual cafe. It has some kind of network endpoint that it has to somehow connect to at the lower levels through, I guess, WebRTC, and that's what the Croquet service coordinates with Rendezvous.
You keep using the word rendezvous. There's nothing to do with bonjour or any of that.
No, I meant rendezvous in the networking sense, not Apple rendezvous.
Okay,
so
good.
Basically, Croquet gives you a distributed object, and the name of that object is 125. And no matter how many people around the world are getting access to that object, they are all in sync. That's how that works.
But in terms of them actually finding each other, it's that Croquet reflector service that plays, I guess, the moral role of like a root DNS server.
Yep.
Okay.
Much.
Okay, got it. Sorry, didn't mean to take the long. Okay. This
would sort of be the punchline for that at the Smalltalk level here. And I'll be going through most of these classes in more detail. I mean, as time permits. It's already only 7 minutes left to when we usually stop the talk. Yeah, there's a Smalltalk class which plays the role of a Croquet view. And on the class side of that thing, you can join a session with a set of credentials. But there's a lot more involved. All I meant to say before is that there's a lot more involved than just that number 125. But as far as someone who just cares about WebRTC and Smalltalk, that's all they need to know. But there's actually more to it. Not a whole lot more, but some. In particular, there's a little identifier that is similar to a domain name, internet domain name, that's also involved in identifying a Croquet session. Does that kind of make sense, Mike?
Yeah. I just I didn't know about this persistent service out there on the internet. That explains how two systems that don't know about each other can somehow find each other.
Yeah, exactly.
That's what I was asking. Okay, cool.
And yeah, Croquet sort of out of the box is providing, it's got this event system that I mentioned before that lets you subscribe to and publish events that go out to various scopes. So like there's a scope that means all participants in the session will get this if they've subscribed. And then you can have finer scopes, like the very finest one that I use when one peer wants to relay a message to one other peer. One of the two of the events that you get sort of out of the box are just that someone has come into this session and someone has left the session. You sort of get those for free in any Croquet session, no matter what your higher level application is. Yeah, so I didn't have to implement that. If you go to the Croquet docs site, you'll see the events view join and view exit. That's what I'm talking about. So let's see. So several times now I've switched tabs and replayed what happened to get to this point. But I'm not going to talk too much more about what's going on here in these DevTools transcripts because we already sort of got the fun part, which was seeing data go back and forth in both directions from both places. Instead, I'd kind of like to talk about what's going on, at the Smalltalk level when you're dealing with this stuff. And I'll kind of just start at the top. in Squeak.js, there's a JavaScript bridge that lets you create Smalltalk objects which are proxies for JavaScript objects in a very seamless way. And you get a global called JS, which represents the web browser window you're running in. So you can evaluate things, if you happen to know the web browser window API, you can do things like, say, call the alert JavaScript function as if it were a Smalltalk method. So here's a little notifier from that running. So, as soon as I saw this the first time, I thought, oh boy, here we go. If I can send, Smalltalk block closures as callbacks and make promises out of them, JavaScript promises out of them, then I'm home free. I can make mashups of Smalltalk with, any JavaScript framework there is, and bring a true live coding style to it. And there are a bunch of interesting frameworks out there. So I immediately, dove into virtual reality stuff and had a lot of fun there. And yes, indeed, I've been able to use every JavaScript API I've come across perfectly fine from Squeak.js, and the performance has been, fine also for every app I've made so far, including all this, 90 hertz frame rate VR stuff I've been doing on lots of different devices, everywhere a web browser runs, not just here on my desktop, but also on my phone, on iPads, on my VR headset. So that's really exciting. So the first thing to notice here in this hierarchy is that I'm using a class I made, which is not the base level JavaScript proxy class. That one is called JS Object Proxy. I came to notice in pursuing these mashups that it was useful to have a bare bones proxy class and a separate class which holds on to an instance of that bare bones proxy class, but is very distinct. And this was in the beginning. This was to avoid, system crashing or system hanging problems I was having with the use of super. But after thinking about it some more, I also decided that it was actually conceptually a useful thing. So it may stay this way. I have some ideas about making this thing a subclass of JS Object Proxy instead, but I'm sensing it's gonna stay this way. And hopefully you can read these class comments as I go by here, even though I may not linger on them for very long. Everything you're seeing tonight will be part of the release snapshot on caffeine.js.org in a few hours from now. So the other thing that sort of sealed it for me about keeping these proxy classes separate was that in addition to all the behavior that you would add to a subclass of this thing to make the JS APIs more approachable, like documentation and aggregate behavior that combine normal Smalltalk behavior with JS behavior that you're accessing over the bridge. You also want to make sure that the behavior you're adding, just so that these objects show up coherently in the Smalltalk development tools, don't affect how the bridge works. It's just another version of the motivation for having a separate proto object and object class. Although there's some irony there. I think this proto object case, the motivation is not nearly as strong. And in the module system I mentioned before, Naiad, I've actually gone back to not having proto object at all, and it's turned out to be a lot nicer. Okay, so we've got that. And moving down, we've got a thing called JS class, which lets us create JavaScript classes, which were relatively recently introduced by ECMAScript 6. It's a little bit crude still at this point, but it gets the job done for the first two Croquet apps I've done, Beat Shifting and WebRTC. It lets you, fairly conveniently from Squeak, from Smalltalk, create an actual ECMAScript 6 class in the JavaScript runtime. And at the moment, this actually does involve literal strings that have JavaScript code in them. And there are pluses and minuses to that. I mean, certainly if you've been writing Croquet apps in the normal way with handwritten JavaScript code, then this is very readable. And by not doing anything fancier, you're sort of removing from the bullets from the foot shooting gun. Yeah, and I try very hard not to do anything more clever than it needs to be until I'm feeling a certain level of pain from not having done it in a particular real app. So yeah, we'll see how that goes. But fortunately, in most, well, at least in these two Croquet apps I've written so far, there's just not a lot of code, so it hasn't gotten anywhere near to getting out of hand. So I won't go too deeply into what that JavaScript code actually is, but I'll just mention in passing that the cafe and the peer are both done this way. And if you happen to be familiar with the Croquet APIs, then this stuff will look, extremely familiar. The most important thing is just this is where you set up the things, the events that you're going to publish and subscribe to in a Croquet session. So yeah, now we're getting more specific to a particular app. I've made a common superclass for Croquet models and Croquet views, which is called Croquet Peer. There's that word again. Not too overloaded, I think, so far. And this is mostly so that I can implement the special tricks I need to do from the Smalltalk side. Oh, see you, Ted. Thanks. From the Smalltalk side of the JS bridge, to be able to publish and subscribe to events, live after the session is started. Mike, before you mentioned the island concept, that is also in the current implementation of Croquet. And the trickiest part of doing this Croquet app was being able to make things happen on island from the Smalltalk side of the JS bridge in Squeak.js. So there's some trickiness that needs to happen for that to work. And it's a collusion between the the normal Smalltalk code in Croquet Pure and its subclasses, and in the actual JS code that the Croquet model class uses at the beginning. In particular, I sort of commandeer the tick function in Croquet, which is normal Croquet, to service requests to run functions from Smalltalk.
So one little thing that might be confusing me, maybe just because I haven't looked at Croquet for 15 years, is I'm noticing the Croquet stuff is subclassed off of the JavaScript stuff like JS class and JS object, and I mean, what about? I mean, I remember Croquet just running in an ordinary desktop Squeak. I don't think there was actually even a Squeak.js at that point.
Right.
So I'm a little confused as how the Croquet stuff is now underneath JavaScript stuff. When I remember it being like a pure Smalltalk stuff.
Right. So this is a way. I mean, this incarnation. I mean, Vanessa, jump in if I get any of this wrong. But this incarnation of Croquet is a way of bringing the distributed computation ideas from, I guess, classic Croquet, if you will, to the JavaScript ecosystem, so that you can have, peers which are well integrated with other JavaScript things like
you mean
VR game frameworks.
But do you mean independent of what you've done? I mean,
yeah.
Well, so it sounds like what you're saying, and maybe I've been asleep for 15 years, that the Croquet you're talking about is JavaScript native.
It is, and it's new.
Oh,
new.
Well, that explains all of my confusion.
Yeah.
Oh,
this is a new thing. Yeah.
Boy, do I feel old now.
Oh no. This is a new thing.
We're gonna launch really soon now. So.
Yeah. Oh, so when you say Croquet, you're really talking about Croquet.js, right?
Croquet.io. Yes.
Yeah, Croquet.io. Yeah.
So basically, it's taking the architecture and ideas of Croquet and re-implementing them in JavaScript, similar to the way Lively kernel kind of takes the Smalltalk ethos and applies it to the JavaScript world.
That's not the worst comparison. Yes.
Okay.
Yeah.
Probably giving us too much credit, because Lively is a lot more like Smalltalk than the new Croquet is.
Right. Yeah, that summary might be a little aspirational, but I think it's good if you squint, and maybe completely correct as time goes on. I hope so. So let's see. Getting back to my class comments. Okay, so both because of what I'm doing with Croquet Pure and how it works together with the actual JavaScript code that instances of concrete subclasses make, I can do things on island as I need to, especially
so
in the Croquet model
like
when I
there's
publish.
no way that could possibly work, but obviously it works, and I'm amazed.
It does work. Yeah, there was a point where I was thinking, damn, I can't do this. But then I realized tick was the key to doing it, because tick is on island. Yeah, I went through, I mean, I tried to do it without resorting to that for quite a while, and I realized there may be a way of doing it if I could actually see all the Croquet source, but I couldn't. It was all minified, and I ended up thinking I would probably end up modifying the Croquet source in some slight way, and I just don't want to do that. So the tick solution, even though it's also a little bit diabolical, I think is reasonable ultimately. And it has no ill effect on performance, which I really like as well. Okay, so given croquet peer, moving further down to croquet model. Is there anything more really to say about that? This is where you see the the trickiness actually happening from the Smalltalk side when you want to invoke a function. This is where I'm pushing the function name, the name of the function I want to call on island and its arguments. And satisfying croquet's requirements for the parameters, for the arguments you're sending in such a way as they can be part of snapshots took a little bit of thinking to get right, but that does work. And the Squeak.js JS bridge itself, also has some requirements about what you can pass. But I managed to satisfy all of those things, and it works fine. And there's no real limitation. There's nothing I would want to send that's not sendable. Although, as we'll see later, to reduce the cognitive load on the Smalltalk programmer, I did end up making something which uses JSON, the stringify parse way of doing JavaScript serialization to pass some things. But I'm very confident that in my croquet things, in my croquet apps, those things that I want to send in these, what I call envelopes, are not going to be, tricksy things. They're not going to have weird circularities or anything like that. So using JSON in this way, I decided was perfectly fine. But we'll maybe get to that a little bit. I don't want to go on too much longer. I want to try to wrap up this talk by 1/2 so that there's half an hour for people to hang out and talk again if they want. So there are some other classes here, some other subclasses of JS class and croquet peer, which have to do with the previous croquet app I spoke about in another meeting, the beat shifting app, that are not part of WebRTC. So sorry for the clutter, but score and orchestra are part of beat shifting. They're not part of WebRTC. So skipping past score, we get to WebRTC Cafe. And this is the thing, like I mentioned before, that's sort of managing the arrivals and departures of peers in a more WebRTC specific way, handling service announcements from peers and messages that peers are trying to relay, both between pairs of peers and the model and everyone in the session. In particular for WebRTC, that includes session description protocol offers and answers and ICE candidates. And those are, I guess at this point, I'll just say WebRTC things that need to go back and forth in the signaling. I guess at the very end, we'll look at that diagram again about WebRTC. Some typos. So now we've got croquet view. Oh, I really haven't written that comment yet. I apologize. There's not really much magic going on for that to work. There's just sort of some syntactic sugar. It takes advantage of the trick that croquet peer and croquet model have already set up. And it so provides a less verbose Smalltalk API for the Smalltalk programmer. But yeah, the only protocol that's there has to do with initializing yourself, leaving a session, figuring out some details about your session and your own identity, and dealing with events, publishing and subscribing. So a subclass of that is WebRTC peer. And yeah, the most important part of this so far from the programmer's point of view is just the list of references I've provided about where to read more about all the APIs involved and how you get at them. But as we look here, these are handlers I've been able to write in Smalltalk that respond to events, croquet events that to which the peer has subscribed. So with all that plumbing sort of taken care of for you, you really can just focus on writing, handlers for all these things. And if something goes wrong in the middle of one, you can, open debuggers and debug them, and in many cases just proceed from the beginning of that context, and the signaling actually continues properly. As we may see later, if you ask about it, the way the WebRTC signaling works is, quite forgiving, and it sort of has to be inherently, because what it's mainly concerned with is advertising the capabilities of one peer with regard to what kinds of media it can handle, video and audio in particular, because WebRTC's main motivating use cases for telephony and video, things like Zoom and things like 8x8, which we're using now, is very complicated, very complex WebRTC app. So you've got all these descriptions of what peers can do flying around, and the sort of peers are trying to negotiate when they're doing video calls, sort of the highest quality connections they can make. And those negotiations continue even after connections have been opened and people are actually having video calls, for example. Always trying to negotiate something better if something better becomes available, and always trying to be able to fall back to the best option that remains when things get worse. And yeah, I'm sort of amazed that it works so well. The signaling and everything that happens after the signaling is so complex that it took a while to get right. I first heard about WebRTC, I guess, in 2013, and looking back over discussions of developers writing apps for against it, I mean, it seems like things only really got smoothed out in the last 2 or 3 years. So it's an amazing effort. I'm trying to find. So now I'm going to try to look at one of these that's a little more complicated. There are some of these that involve multiple levels of JavaScript promises. I may have to resort for looking through. Oh yeah, here's one. This kind of stuff is totally hellish to debug in handwritten JavaScript, but it's not here done this way. So you have all these great things coming together. The way the Squeak.js JavaScript bridge works. And the way that the WebRTC signaling protocol has been, finally hashed out after all this time. If things go wrong, anywhere in here, things still remain, fairly coherent. And so, as a developer, I would say this was kind of the big payoff of this whole experiment, was that writing stuff like this was not monstrous. Okay, so we've talked about the croquet model in Vue for this example. And now it's down to sort of these utility objects that the model and the views use to do what they want to do, that have to do with your particular protocol that you're trying to write for. So for beat shifting that I spoke about in another meeting, there were these time signature changes and appointments to schedule notes in a shared music session. And here there are these things they would briefly touched on before, these connection offers and answers, and candidate descriptions of capabilities. And I guess at this point, I'll just say that these are all things that you can go to the trouble of making an entire JS class with a proper JS constructor for, and that Croquet will know how to serialize right off the bat, or you can just stringify it as JSON and send it in a Croquet envelope and parse it on the recipient side. So yeah, that kind of goes through the hierarchy of classes that are involved in this example. And I just wanted to finish by looking a bit more at what's actually going on in WebRTC. And I highly recommend looking at this diagram. I'll put this link somewhere on the YouTube page for this recording. And it will also be in the caffeine snapshot we've been looking at. But this is when things really made sense for me about WebRTC. There are two diagrams. There's this signaling that happens, and that kicks off this other thing which goes on at the same time, this way of exchanging ICE candidates that describe what each peer can do. The basic idea is a peer notices that another peer exists and decides that it would like to establish a connection with it, and then it offers to do so. And in this example, we're talking about a caller and a callee. And so when you respond to an offer, that's when these ICE candidates start flowing. And so this was sort of the part that it was never very clear to me, was these little bubbles here, these processes that start happening because of a state that has been reached in this initial conversation. So once the calling peer has decided that it would like to make a connection, then it can offer to do that, and the potential callee can say, yes, I'd like to do that, and make an answer to that. And then they start sending these candidates, the capability candidates, to each other. And once there's been a consensus about what these two sites can do in a way that would actually work, then the connection is actually made. And even after you understand both of these diagrams, there's still a ton of stuff that's going on behind the scenes. In particular, this process involves another server, distinct from the Croquet server, that's used for actually setting up the data channel connection. And in the example I showed today, I was using something called a stun server. And we can talk more about stun if you like, but sort of the point of all of this is I'm trying to hide all of that and even these diagrams from the Smalltalk developer's point of view. So I don't know, maybe in future versions of this talk, I'll have a better way of just sort of running through all of that in very little time. But at the moment, I think it's better to just say that it exists, and there are these external servers that need to be running. So I'm using two of them, basically, the Croquet service and this, I'm using a public stun server. And I'll probably end up setting up my own stun server. Would anyone like me to go into more detail about that? I'm sort of trying to wrap this up because we normally stop by past. If not, then I'll just reiterate that I keep fairly current versions of this snapshot at caffeine.js.org. And this demo that I showed just now would probably end up being another entry point in this list of demo entry points. I already have some that show off a single page application done with Caffeine, another one which is a spatial computing live coding space that you can use in VR with a headset. Beat shifting is there now also. Also, demos of how you can run Pharo and Kuis this way, and a bunch of other stuff. But this is where I would look first. And this snapshot that I just showed will be there pretty soon. Sorry?
I do have some very basic questions. So when you executed this WebRTC peer join session named 125, you already had the cafe running, right? Somewhere. You had started, or was it started as a side effect of the first time you did a join session named?
The latter, yeah. These two snapshots, when you first saw them, they had just been loaded from a web page, and the Croquet service knew nothing about us.
Right, and I see that you have then WebRTC peer current, so it's a singleton. So, or can you create multiples? Would you join multiple sessions? I'm trying to understand. Oh yeah,
you totally would. This is just an artifact of this Hello World demo that there's a singleton. Okay. Normally there wouldn't be. Normally I would expect that there would be some top level thing which represents the kind of service that you're talking about, either this object memory snapshotting service I mentioned or this history service thing I mentioned. And that's how you would get at the peers that are relevant to that service. Yeah, this is purely just for this demo.
Okay.
So I'll say thanks and ask if there are any more questions.
Well, thank you very much.
I got a quick question.
Yeah.
Let's say, this isn't a croqueting, just in terms of like Squeak.js and its extensions through Caffeine. Let's say you wanted a Squeak desktop image to talk to a Squeak browser image.
Mm-hmm.
What would be your suggested pathway?
Well, the kind of critical path between the Smalltalk here, whether it's running in a web browser or natively with COG, is WebSockets. And WebSockets work perfectly fine in both places. So both Squeak.js in a web browser and Squeak running on COG would have no problem speaking.
Okay, so there's a WebSocket implementation in desktop Squeak. Then you would just go WebSocket to WebSocket.
Yeah, but cool. I should say I haven't done the work of making the COG example actually demoable. I've been focused totally on running things from web browsers.
I got to say, just I tend to stick to Visualworks and trying to bridge between website. I've had to use sort of external shims to do that path.
Mm-hmm. If I really wanted to show this working from COG, my first attempt would be to cheat and use a Squeak.js or Node, or Squeak.js running under Node instance somewhere to do that, because I have it all working already.
Then you could use the Node's native TCP, or
it's WebSocket support, yeah.
Well, that's cool.
Then because you've got this the Croquet code that you can just use by including as one of the scripts in your JavaScript runtime environment. So it's very straightforward to just include that in your web page and probably in your Node system, although I haven't done that yet either.
I like the Node idea. That's a good one. I hadn't thought of that. Cool.
Yeah, and I should say as an aside that as part of my Caffeine work, I've also made Squeak.js run quite well inside. In fact, I even say it here on this page, inside a web worker that's running either in a web browser or in Node.js, or even as a Chrome DevTools panel. So yeah, I would probably end up using Squeak.js somehow, even if I were trying to make it look like it was running in COG, because Squeak.js runs pretty much in every JavaScript runtime that I've come across.
Right. I was just trying to figure out how to bridge to something directly over the OS. But I like your ideas. So cool.
Yeah. There's still some small matters of programming to make that work everywhere you would expect it to work.
Yeah, you need a server somewhere, and you can talk to that server however you want. WebSocket is one idea for, like, if you're on the desktop, you can use it, just TCP or WebSocket or any of that, but Squeak.js really can only talk WebSocket, because that's the only, well, that and WebRTC, that's the two streaming connection options you get in JavaScript in a browser.
And there will be, I guess, quick options coming soon, as all the web browsers will be supporting that as well.
Yeah, that's going to be interesting.
Yeah, so that if anyone hasn't heard of it, that's sort of the sequel to TCP and UDP. There'll be sort of a third option there.